Hi, my name is Malte Vöge and I will guide you through this e-poster on remote sensing of tailings storage facilities. Tailings are a byproduct of ore mining. They often contain huge amounts of water or chemicals and often consist of a slurry of fine particles. They can be toxic and environmentally hazardous. Examples are sulfides, aluminum, and copper mining. Tailing storage facilities are embankment dams containing the produced tailings. Often they are constructed with local, non-ideal materials including tailings themselves. The dams are usually constructed in stages as the production of the tailings continues. The upstream dam design is the most common one, where older tailings support new dam extensions. However, they are also the most vulnerable to structural problems. Our first case study is the Most Dam in Poland, which is the largest tailings dam in Europe. It contains tailings from copper mining and is an upstream dam of about 70-meter crest height. We processed 53 Sentinel-1 images between October 2017 and March 2019 with both SBAS and PS workflows. Here we see the line-of-sight displacements from the SBAS and the PS processing. Clearly, the SBAS results show the much better coverage all over the dam. The figure to the bottom right shows an example for a local displacement pattern that is much better visible in the SBAS results than in the PS results. However, the large settlements on the tailings themselves, close to the dam crest, the so-called beaches, appear to affect the SBAS results. We assume that this is an effect by the spatial filtering of the SBAS processing workflow. We also process decomposed vertical and east-west horizontal velocities from the given ascending and another descending Sentinel-1 stack with the SBAS method. The vertical velocities show a similar pattern as we've seen it for the line-of-sight displacement. The horizontal velocities, however, reveal that the dam itself is moving outwards while the tailings and on the so-called beaches are moving inward. Our second case study is the Vöge mine tailings dam collapse that happened on the 25th of January in 2019. This dam is a horseshoe-formed dam constructed in 1976 in Brazil. It is connected to iron ore mining. It is an upstream dam of 86-meter crest height. As you can see from the video, this was a complete failure of the dam and it caused over 200 casualties. We processed 100 Sentinel-1 images in descending mode in the period between 2015 and January 19. Again, we process with both SBAS and PS workflows. Here we show a comparison of SBAS and PS results for the entire area for a subset of 62 scenes from January 2017 to January 2019. The SBAS results show again much better coverage. Marked with a red rectangle, we see the dam itself, but also several other mining sites are visible as subsidence patterns in the SBAS results. The close-up to the dam shows a similar pattern as for the Most dam, with highest velocities near the crest of the dam and on the tailings. The average time series for the upper and the lower part of the dam show almost a linear displacement with only slight variation. Only when we focus on the very center of the dam marked in the red rectangle, we can see what appears to be an acceleration about 1 to 2 months prior to the dam breach. However, this variation is not much stronger than other variations in the same time series, and therefore we cannot conclude that this is a clear precursor to the dam breach. In conclusion, we would like to say that INSA is a very strong tool for long-term monitoring of the stability of tailings dams, but that careful interpretation of the results is necessary. PS and SBAS have their respective advantages and disadvantages, and the temporal sampling seems to be rather coarse to do an actual early warning.